Okay, so now we're going to talk about measures of central tendency. So chapter 3. Okay, so this chapter or this section is actually pretty straightforward. There's very little when it comes to it. The bulk of it would be in the next section when it comes to standard deviation. But for this one, we're going to define a couple things involved as well. Okay, so if you actually go in your book or in your books, a lot of the times these definitions are not in there. They're actually given to you in chapter 1, which will, I skipped itself. So essentially, chapter 1 is given a lot of definitions, and I don't want to bore you guys, for that. So what I do is I just pop them in when you actually need them, and this is instance the first time we actually need these two definitions from chapter 1. Okay, so the first concept is called population. So population is the complete collection of all individuals to be studied. The collection is complete in the sense that it includes all individuals to be studied. Now, when it comes to, let's say, biology or chemistry and stuff like that, right? We have different types of population. So a population can be, animals, us, organisms and stuff. But when it comes to statistics, it doesn't have to be organic, meaning it could be non-living. We can be talk about numbers. We could talk about computers. We could talk about how many toys someone has. So it's non-organic. So it's anything you're actually studying itself. So that's what a population is. Now a sample is a sub-collection of members collected from a population. So here's an example. Let's suppose we're doing a survey in the college and asking students who like Star Wars, for instance. So the population will be all the students at Chaffey College, for instance, right? So a sample would be surveying, let's say, the stats classes. So since the stat classes only have 30 students, it's a sample of the entire population, right? So that's what that means. So a sample is just a sub collection of the entire population when it comes to it. So easiest way to think about it, you can think about if you're doing a survey, you obviously can't survey everybody in the United States. So they do a sample, right? They pick here, pick there, and then put that together. So that's called the sample of the entire thing. Now, when it comes to stats, obviously we're going to be dealing more with sample than population because it's far easier to do a sample than find the entire everybody in the population to deal with, right? It's almost impossible to do that kind of stuff itself. Okay, so next thing we're talking about is something you guys probably have already heard before. It's called average, or in our case is the mean. Okay, so that's our first central tendency. So it's the data set so the mean is the data set or average of itself. So the mean is the value at the center of or the middle of the data set, and it's calculated by adding all of the values up and then divided by the numbers we have. Okay, so it's a very simple example equation, or way of finding it is we literally add up all the numbers together. So we just literally add all the numbers up and then divide by how many numbers we actually have. So here's a little example, right? So here's our data set. And we want to find the mean of the data set. So first off, we add up all the numbers, which should give us 17. Okay. And then next thing we do is divide it by how many numbers we have. So how many numbers total we have? 1, 2, 3, 4, 5, 6, 7. So what's 17 divided by 7? About 2.43. And in this class, worst comes to worst, what you really want to do is always round to two decimal places. Okay, so if you're ever not sure, always round to two decimal places. Usually we told to you when it comes to it, but if you're not sure, always round to two to be sure when it comes to it. So our answer will be 2.43 in this case. So just a little quick rule of thumb. Now, when it comes to this, so obviously that's pretty straightforward, right? Add them and just divide by how many you have. But the problem is, when it comes to your equations, a lot of your equation sheets will not tell you the wording. It's going to give you an equation or a formula to do that. So what we want to do in this scenario is we want to actually list out a couple of different variables involved. Okay, so the first thing we want to do is something called the sigma. Okay, so um, yeah, so let's talk about this symbol there. It's a fancy E. So it's a Greek letter. It's called sigma. Okay. So in our case, sigma represents sum of things. Okay. So sigma represents sum of numbers. Okay. And all that says. So when you see that symbol, what that's saying is we're just adding stuff together. Okay. That's all that really means. Okay. So next thing we want to do is n. N or capital N. We'll see a little bit as well. Okay, so N represents, or capital N, the number of data values we have in the data set. Now the cool thing is N will always be that exact definition. What I mean by that is sometimes different variables have different definitions according depending on what chapter you are, but n will always have that definition no matter what. So n represents the number of data values we have itself. Okay? And in this case, x represents the data values in our sets. Okay? So the reason why we do this now, notice, instead of me saying you add up all the numbers and divide by how many data values you have, I can rewrite that in a nice equation or formula. And it's going to look exactly like that, where you write sigma means the sum of all the data values, and you divide by the total number you have, or n itself. So this is how you're going to see a lot of it in your formula sheets when it comes to it. Right? It's not in worded. They're going to give you the exact formula of it, and you're going to have to know what the symbols represent itself. Okay? So when it comes to this going forward as well, the next section, most of the time the population and the sample are going to have different equations. But in this case, the exact same one, which is nice, but the symbols are different. So believe it or not, in the next couple sections, you're going to have to learn a couple new symbols representing two different things. Now, the good thing is, they're not going to straight out, throw you to the wolves and have to memorize it, but slowly transition to you, instead of saying sample mean or proportion mean, break it down when it comes to it. Okay, so x bar, so this x with a bar is sample mean. So the mean of the sample. Okay, so this is not supposed to have a bar, but mu, again, it's Greek, is population mean. Right? So if you see x bar, that represents the sample mean. If you see this fancy u, that represents population mean. Okay? So later on in the course, again, they'll slowly transition you. They'll stop saying the words, and they'll give the symbols, and it's your job to know which symbol they're dealing with and what they're talking about. So that's where they slowly transition to in this entire chapter. You'll see that as well. Okay? That's pretty much the first type. It's just the mean. So we just literally add up all the numbers and divide how many numbers we actually have. And then you get, rule of thumb, always round to 2 decimal places itself. Okay? So the next thing I want to talk about is the mode. Oh, sorry, not the median. Okay, so median of the data set. Okay? So the median is pretty straightforward. It is the exact middle number in the original data set, arranged from increasing order. Okay, and right here we're just going to quickly just do some examples so you can see what that means. So we have, let's say, 5, 8, 10, and 15, 20, 21, and 20, let's say 31. Let's just say we have that. And we will find the median. Now, the easiest way I can think of finding the median is you start from one end and the other, and you slowly go towards the middle. So what I like to just cross, 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 you found your median. So in this case, the median would be 15. Okay? And there's actually no little symbol to illustrate median, so they'll literally just say median. So in this case, so that'd be 15. Let's just try another example. Let's say 0, 2, 9, 12, 14, 1. Yeah, let's do that. Okay. Now I'm trying to trick you because remember it says in a range order, right? Increasing order. Now this actually is not increasing order because 1 is not bigger than 14, right? So we just firstly have to rewrite all our numbers first in increasing order. So we just got to pop that in the front. Now we can do the same thing I did above, just crisscross. So cross, 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 cross. Got a problem. What is it, right? Because I can't cross them both out because there's nothing in there. So what we do is, right, we want to find the exact middle. Well, this goes back to finding the midpoint. So section ago, how do we find the midpoint? Add them and divide by 2. And that's exactly what we do here. We add these two numbers and divide by 2. So 2 plus 9 gives you 11. And 11 divided by 2 should be 5.5. So our median is equal to 5.5 in this case. So we actually had to do a little bit more work and it wasn't exactly in the middle. But same exact concept when it comes to it. So whenever we have two numbers in the middle, we add them and just divide by 2 to get the exact middle. So literally exact middle itself. Okay. So that's the median.